All right, good morning and welcome to Master Talker online class. In today's video, I want to do a summary of all the motions in physics. All right, don't forget that Master Talker channel brings you about all the calculation in math, physics, and chemistry. So please, if today is your first day of watching my video, just click on that red subscribe button so that anytime we drop a video, YouTube will notify you. All right, and please like and comment on this video to help the video go viral. Okay, thank you very much. Now, in motion, there are a few things you need to know. In fact, the only three things I need you to know in motion is the three equations of motion that say that V is equal to U plus AT. Okay, equation 1. Then V squared is equal to U squared plus 2AS, equation 2. Now, S is equal to what? UT plus what? Half AT squared. Now, once you know these three equations for me, equation 3, now the next thing you need to know is that retardation. Okay, now let me, from this place, I want to explain these three things. These three are very, very important: initial velocity, final velocity, and acceleration. Okay, now once you hear that a body starts from rest, the body is already at rest, it started from rest, your u initial velocity must be 0, while your final velocity will now be the velocity given to you because the body start from rest. And anytime a body start from rest, it means that acceleration must be positive. Acceleration must be what? Must be positive. Okay, in fact, it is called acceleration. Whenever it is whenever a body is accelerating, they can tell you that a body start from rest or accelerating. Whenever a body is accelerating, or maybe your acceleration is positive, then your u must be 0. Or if your u must be 0, then do I say 0? Okay, let's say whenever u is smaller than v, something of that nature. Or but whenever you hear that it starts from 0, it starts from rest, know that you are talking about acceleration. Right? You understood that one. Now, whenever a body is now going to rest, it is called retardation or deceleration. And retardation is negative acceleration. So if your acceleration is negative, you're going to use negative in your acceleration, then you are talking about retardation. Or whenever you know that your final velocity must be 0. Remember, if you start from rest, initial velocity is 0. But if it is going to rest, you apply a brake, you want to stop, then the final velocity is going to be what? 0. And it's called retardation. It's called retardation. Then you are done with linear motion. This first one is linear motion. Let's talk about linear motion. If you know just these three concepts I just said, you are done. Know your three equations of motion, then know that if a body starts from rest, then you are talking about acceleration. And if you start from rest, your initial velocity must be 0. Then if a body is going to rest, then the final velocity must be 0. All right? That is that for that. Now let's talk about objects thrown vertically upward. Objects thrown vertically or vertical, let me call it vertical movement or vertical motion. Okay, vertical motion, let me call it vertical motion. Now, for vertical motion is in two ways. The same way we have acceleration and retardation here, the same thing happens to vertical motion. It's either a body is thrown vertically upward, or maybe the body is coming down from a height. Now listen, if a body is thrown vertically upward, is that body moving against velocity, against acceleration due to gravity, or towards or in the direction of acceleration due to gravity? It is obviously opposite. Look at, if I throw something upward like this, acceleration due to gravity is moving downward. So if you throw something upward, it means that your acceleration due to gravity must be negative because it is moving against gravity. And I told you here that if acceleration is negative, what do we call it? Retardation. So any object thrown vertically upward is in retardation. And if something is in retardation, what happens to velocity? Velocity is 0. So here I have that my what? For this object, this one is thrown vertically upward. object thrown vertically upwards. Okay, now if you throw it vertically upward, it is moving against gravity, so therefore what happened? Your g is negative, and if your g is negative, show that your final velocity must be zero, because it is retardation. Please, I told you that what, in retardation your acceleration will be negative, and if acceleration is negative, then your final velocity will be zero. Your final velocity will be zero. Your initial velocity will now be any velocity given to you, or maybe they will ask you to find that velocity. Now, once you know this thing, come back to your equation of motion. We now have that the first equation of motion is what? V is equal to u plus at. So what do we have now? Our V is zero for this. This is zero, is equal to u plus, now your A will no longer be normal acceleration, but what? Acceleration due to gravity. But what happened? It must be negative. You're going to have minus g, then you put your t. So I'm having 0 is equal to u minus gt. Correct like terms, you now have that what? Your gt is equal to what? U. Okay? Then if you're looking for t, obviously it's now u over g. Now, this formula I wrote, you don't need it. Yes, I said it. You don't need. All you need is just know your equation of motion and know when you are doing retardation and when you are doing acceleration. Forget about this derivation. I'm just showing you something normal. You don't need this formula to cram this formula. No. All I need you to know is this three. Once you know this three, you are done. Anything motion, you are done. Okay? So just know that once you know this three, know that if it is thrown upward, I'm having negative gravity, and negative acceleration means what? Retardation. So this man, when an object is thrown vertically upward, it is retardation. But when an object is falling from a height, object falling from a height, falling from a height. Now, if an object is falling, is already at a height and then is falling, is it moving with gravity? Yes. Since it is moving with gravity, my g must be positive. And if my g is positive, what do we call it, child of God? We call it what? Call it what? Acceleration. If your acceleration is positive, it is normal acceleration. And if it is normal acceleration, what does it mean? It means that what? Your initial velocity must be zero. Then your final velocity will now be that velocity given to you. Okay? Now, I did for only this one, though. The same thing is applicable here. Just that you will change your V for this particular one now. If you want to do this one, for this, for here, for object thrown vertical, your V is zero, your U must be given. Your G will turn to what? Negative. Your A will turn to negative G, and your S is height. S is distance. The distance will now change to height. For this one, I'm going to have, I have V squared is equal to U squared plus 2AS. So I'm going to have 0 squared is equal to U squared plus 2 into minus G. Distance will turn to height. Displacement. You know, S is called displacement. Your displacement will not turn to height because I'm not moving linear. I'm talking about something standing up. So it will turn to height. Very simple. So I have that what? 0 is equal to U squared minus 2GH. This one coming, you have that 2GH is equal to what? U squared. So my H will now be what? U squared over what? 2G. I hope you know that this is the time to reach the ground. The time, okay, sorry, the time to reach the maximum height, because you are throwing it upward. The time it will take you to reach the maximum height. Okay, that's what they will ask you for this. But you don't need this formula. Once you know this one and know what you are doing, you're okay. This one is the time to get to, so this is what? The maximum height itself. The formula to calculate the maximum height, that's U squared over 2G. You don't need this formula. What you need is what? Once you know these three things, and then you know that it is thrown upward means negative gravity, and negative acceleration is what? Retardation. Then you know what to do. The same thing is applicable to the last one. Your S turn to H, your U, you know your U, and then your G, your A will turn to what? Minus G. Very, very simple. Very, very simple. Okay? So that is that. So we're not talking about when a body is falling from a height. If a body is falling from a height, it is moving in the same direction with gravity. And if it is moving in the same direction with gravity, it's going to be positive. And positive acceleration means normal acceleration. So your U will be zero and your V will be any velocity given to you. This confuses students all the time. They don't know when to use when their initial velocity will be zero or their final velocity will be zero. But if you know this concept I'm telling you now, you are done. you are done. So the same thing, apply them here. The same thing again. Your G will now be positive G. Your U will be what they gave you, and your U will be 0, and your V will be what they gave you. In all of them, don't forget that the displacement will change to height. Very, very simple. So I'm going to have for this one, I'm going to have that V is equal to 0 plus what? GT, positive. So therefore, V is equal to what? GT. They will now ask you to find the time it will take it to fall on the floor. Okay? So the same thing is applicable here. That V squared is equal to 0 squared plus 2GH. So therefore, V squared is equal to what? 2GH. The same thing is applicable to the other side. H, because this is displacement, so it will turn to H. H is equal to what? 0T plus what? Half GT squared. So that is that for that. So you see, it's very, very simple. This is for linear motion. Now let's talk about projectile motion. Let's know what happened in projectile motion. Now, in projectile motion, projectile motion. Now, projectile motion is still talking about this man, the same thing. But in projectile motion, the only thing you need to know in projectile motion is that equation 1 and equation 2 is used for vertical motion. Okay, for the vertical, while equation 3 is used for the horizontal. Once you know this thing for me, you are done. You are done. Okay, well, let's go now. Watch me now. Let me just show you the drawing. From the drawing, you will know. Now, this thing moves like this. Okay, now, this is the maximum height. And from here to here is your range. Now, if you look at range is talking about the horizontal distance, and I have an angle here. Sorry, I have an angle here. Now, your range is talking about the horizontal distance. So if you want to get your range, use equation 3. Your maximum height is talking about vertical. If you want to get maximum height, there is height here, displacement. Use equation 2. If you want to get the time to reach the maximum height, it's still talking about vertical. Use equation 1. You are done. Very, very simple. Okay? So now, well, let's do that now so we can get it. Watch me. Watch me now. I want to get for equation 1. They say that V, that's why I told you that these equations are very, very important. You need to know them. I'm still using it all this while. So I have that V is equal to what? Is equal to U plus what? AT. Now, let me tell you what happened here. First of all, this thing is thrown upward. It's thrown upward. What did I tell you about throwing something upward? If I throw something upward, it is going against gravity. So my G must be negative. And if my G is negative, what type of motion is that? Deceleration. It's not acceleration, but what? Deceleration. And if it is deceleration, your U is going to be what? 0. Is it U will be 0 in deceleration? No, I just want to confuse it. So it's going to be V, or V will be 0. Your final velocity is 0 in deceleration. But in acceleration, your initial velocity is 0. Okay? So now let us put it here and see what happened. Now, this thing is moving, this thing was moving with an initial velocity. Because initial velocity is what is given. The final velocity must be 0 because it is thrown upward. It is going against gravity and it is deceleration. Now, watch me. There is an angle. Now, I want to resolve this force, this velocity, okay? This velocity to stand vertically because I'm talking about, I want to get the time it will take this man to reach the maximum height. I want to resolve this thing to stand vertically. And if I'm resolving this thing to stand vertically, am I moving away from this angle or towards this angle? Remember, we're talking about, I told you equation 1 and 2 is for vertical. So you are resolving this thing vertically. Are you moving away from this angle or towards this angle? It is obviously away from the angle. If I'm carrying these people to stand up, I am moving away from the angle. So don't forget what I taught you about all St. Teresa's College. I'm going to drop the link sorry, on the description. I'm going to drop it there on the description. Okay, the link of motion, my playlist on motion. Now, what's the meaning of all St. Teresa's College? All St. Teresa's College means, all means if you're moving away from the angle, please use sign. If you're moving towards the angle, use cos. And here we are moving away from the angle. So if I'm resolving this man, don't forget that my V is 0 because it is what? It is retardation is equal to your u will not just be u. We are resolving this u in terms of angle, and it is moving away. So it will turn to u sine theta. Why? Away from the angle, use sine. Towards the angle, use cos. So, but I'm moving away now. I'm using sine. Okay? Plus, your A will turn to G. But not just G, but what? Negative G. Because this is retardation. Minus G, then T. Now, this is what? 0 is equal to U sine theta minus GT. Collect like 10. This one coming here. GT will now be what? U sine theta. Then to get the time it will take this man to reach the maximum height will now be U sine theta over G. Very simple formula. This is the time it will take this object to reach the maximum height. Now they can ask you the time of flight, the time it will take him to go up and still come down, which is capital letter T is equal to what? 2 small letter t. The time it will take him to reach up is the same time it will take him to come down. That's why you have 2 times t. And I have already gotten t, which is what? 2 u sine theta over what? G. So if you don't know this formula, imagine you forgot this formula and you remember this one. The only thing you need to know is that what? You are resolving your u with the angle. So, and it is moving away. It will change to u sine theta. And you know that your what? Your g will be negative g. And if your u is negative g, your final velocity must be 0. You cannot calculate anything if you have forgotten this formula. Very, very simple. That's why I say these 3 equations are very, very important. Now we have gotten this. Now let us get the maximum height. Can I clean here? Okay, let me solve it here. Now, to get the maximum height, I told you we are going to use the second equation. We said that what? V squared is equal to what? U squared plus what? 2as. Please let me check if my video is still counting. Okay. 2as. Now, don't forget that a maximum height, we are still talking about what? Vertical projection. Vertical. And if it is vertical, it is thrown vertically upward. And if it is thrown vertically upward, your g will be what? Negative. And if g is negative, it is called what? Deceleration. And if it is deceleration, your final velocity must be 0. And your initial velocity is this velocity. And don't forget that we are still resolving it vertically. And if we are resolving it vertically, this one is what? 0 squared, because it is deceleration, is equal to. We are resolving our u vertically. And vertically means we are taking it away from this angle. And if you are taking it away from the angle, we are going to use sine. So I'm going to say u sine theta. Don't forget it has squared. All squared plus 2 into your acceleration will turn to negative gravity. Then your s will turn to what? Your height. So I'm going to have 0 is equal to u squared sine squared theta minus 2gh. This one will now move here to have the what? 2gh is equal to what? U squared sine squared theta. U squared sine squared theta. So to have that your h, the maximum height, will now be u squared sine squared theta all over what? 2g. So this is the formula for the maximum height. So imagine you have forgotten this formula. Just do the same thing. You know this equation 2 is for the maximum height. Know that you are resolving your u, okay, with the angle, and it is moving away. So I'm going to use sine. Then know that your a will turn to what? Negative g, because it's going up. That's all. Now the last one I taught you, the last one is what? Is to get your range. Now to get your range, you should know something. Your range is your horizontal displacement, okay? The horizontal motion is moving horizontally. Now, since it is moving horizontally, and I told you we are using equation 3, we said that what? S is equal to ut plus what? Half at squared. Now look at what happened here. In horizontal projection, okay, there is nothing like gravity. It's not moving up or moving down. Gravity affects anything that is moving up or moving down. But this one is going linearly. It's moving horizontal. So you should know first of all that your g must be 0. This a will turn to g, and that g is 0 because it does not affect it. That's one. And secondly, you should know that you are resolving your u in terms of this angle. And if you are resolving it in terms of this angle, and we are talking about horizontally, which means I am resolving this thing to come down to lie horizontally. And if it's coming down to lie horizontally, is it moving away from this angle or towards the angle? You see, it is moving towards the angle. And child of God, if you are moving towards the angle, what do you use? You use cos. So your S will turn to H. Okay, not just H, but range. Because the range is in meter. Okay, it's not height. We are not talking about height, but range. This is my range is equal to what? My U, I'm resolving it towards this angle. So it's going to be what? U cos theta. Why did I use cos? Because it is moving towards the angle. Use cos. Okay? Then times the t that I have here plus 1 over 2. My a will now turn to g. And I told you that that g is 0 because it does not affect it. So I have 0 t squared. So 0 times everything is gone. So I'm left that my r is equal to what? U cos theta times, don't forget what we got as our t. Our t gave us, I think, u sine theta over what? Over g. Don't forget, we derived it. So instead of writing my t, I'll put it as what? But this is not just t, because we're talking about horizontal projection. So the time I'm going to use it is the time it will take him to go up and still fall down. So instead of using this small t, it will turn to the big T. And don't forget that the big T is the total time, the time of flight. So it has two there. So this will not just be small t, but just it will be big T. And what is my big T? 2u sine theta over what? Over g. So now, if I multiply, I'm going to have that my r is equal to what? 2u squared sine theta cos theta. Okay. Okay, there's something I want to, okay, cos theta over g. But please, child of God, look at what I need you to know. According to trigonometry, you can watch my video on trigonometry. One of the ratios of trigonometry said that what? That sine 2 theta, not square theta, sine 2 theta is equal to what? 2 sine theta cos theta. Please, you need to know this thing. So now, this is 2, this is sine theta, this is cos theta. So these three things is equal to sine 2 theta. So therefore, my range will now be what? U squared sine 2 theta over what? Over g. So that is that. So this is for what? Projectile. Everything for projectile is gone. So remember the formula or try to drive it yourself. Tell me what you think about this video. I know you are loving it. So please like now. Then share it to somebody that needs it. Then comment. Tell me what you like about the video. Is it the child of God that I'm calling you? Okay, so now let us continue. Now we are done about projectile motion. Now let's talk about angular motion. Angular motion. Angular motion. Now, in angular motion, most of the things they ask is converting a linear something to the angular one. You know that u is called the, or let me say v is called the linear velocity. Okay, while w is the one, omega is not really just a w, like omega. Okay, omega is the one representing v. Omega is now what? Your angular velocity. Okay, now another one you need to know is that what? You need to know that what? Your a is what? Linear acceleration, while your alpha is the angular one, angular acceleration. Okay, angular acceleration. What else do you need to know? Then your s is what? Linear displacement. While your what? Your theta is the one representing this man, which is angular displacement. Okay, now anytime you want to convert this man to this man, okay, know that if you are moving from linear to angular, just multiply by r, the radius. Very simple. So you should know that what? Your v is equal to what? WR. This one moving to this one. Your a is equal to what? Alpha r. This one moving to this one. Your s is equal to what? Theta r. Very, very important to know and very simple to know. Now, another one you need to know is that from your three equation of motion, I have that V is equal to U plus what? AT. Change everybody. I know that V, who is representing V? The omega. So my omega is equal to what? This one will now turn to omega naught, the initial one, okay? Plus, instead of A, I'll call it what? Alpha T, because my A is being represented with alpha. We go to the second one. V squared is equal to what? U squared plus what? 2AN. So what do we call it? Omega squared is equal to initial angular velocity squared plus what? 2. This one will turn to alpha. While this one will turn to what? Theta. Because this is representing this. Then finally, S is equal to what? UT plus what? Half AT squared. So convert everybody. What do you have? Now that theta is equal to what? Omega T plus what? Half alpha T squared. So you know that one. Very, very simple. Now, another one you need to know is centripetal acceleration. Centripetal acceleration. Okay? Centripetal acceleration, we call it AR. Is centripetal acceleration is given by just V squared over R. Very simple. Just know the formula. V squared over R. Okay? V squared over R. Centripetal acceleration. So therefore, my centripetal force, they can ask you centripetal force is now what? You know that force normally is MA. So but this A will now be centripetal acceleration, which is what? MV squared over R. Okay? Now, what is your V? Don't forget that your V, converting it to omega, because sometimes they can ask you in terms of angle. Converting to angle is your WR. Is it not true? I thought that if you want to move from linear to angular, you just multiply by R. So if you substitute here, I'm going to have what? M in bracket of what? Omega R all squared over what? Another R. So what do I have? My centripetal force will now be what? M omega squared, then what? R squared over what? Another R. So this one will cancel one of the R. So I'm going to have what? M omega squared R. So that is that. Okay. So for centripetal acceleration, it's going to be what? Omega squared R. Omega squared R. So that is that for that. So now we are done with everything called. Then you should know that what else do you need to know? Okay, that is that for that. So finally, we now go to simple harmonic motion. Then we have now summarized everything about motion. I hope these formulas are not difficult to remember. Okay, so just if you watch the video like 3-4 times, you'll be familiar with the formula. Now, the last one I want to talk about is the simple harmonic motion. Now, for simple harmonic motion, you should know that okay. Don't forget that W is equal to 2 pi F. I hope you know that omega is equal to 2 pi F, please. 2 pi frequency. And you know that frequency is equal to 1 over period. So omega is still 2 pi over period. Okay? This one is another important formula for angular motion. Okay? So, but let's talk about the simple harmonic motion. Then we are done for this video. Simple harmonic motion. Now, in simple harmonic motion, the first thing you need to know is that in simple harmonic motion, okay, let me define it from what I have here. They said that simple harmonic motion is a to and fro movement of a body along a straight line in which the acceleration A is always directed towards the fixed point, the center, okay, and directly proportional to the displacement from the fixed point. So we should know that what? That acceleration is directly proportional to what? Displacement. Some people use X. Some people use X as the displacement, while some people use R as the displacement. Anything you like, you use. All right. Then the next thing we should bring in is the proportionality constant. So my A is equal to, now the proportionality constant here, this is directly proportional. Okay. The proportionality constant we're using here is what? Minus K over M, please. Okay. You now put your R. So you should know that your A acceleration is equal to what? Minus K over M, then R. Okay. Then you should know that the The negative sign shows the effect of the what restoring and returning force. This negative sign you are seeing here is talking about the restoring and returning force. The force do restore or return, and as it's restoring and returning, is reducing. That's why we have the negative there. Now, another thing you need to know is that what else do you need to know? Okay. Now you should know that I'm trying to get something. Okay. Now from here, we know that let me move this man to this side. If I move this man to this side, I have that. Okay, leave that formula. This formula is very, very okay for you. Just know that A is the direct proportional to R, and the proportionality constant we are using is minus K over M, where M is the mass, my R is the displacement, my A is what? The acceleration. Okay, my M is the mass, then my R is what? The displacement. Displacement. Some use X. Anyone you like, you use. Okay, so now another thing you need to know is that let me check out one or two things here. Okay. Don't forget that A is equal to minus omega squared R. How do we get this? Now, let me show you how we got this. Do you know that? Do you know that? I want to show you something. Let me show you something now. Look at this. Let me bring this down. I have that A over R is equal to minus K over M. Okay? You should know that omega is inversely proportional to M. Is inversely proportional to M. Then to bring in your constant, W is equal to what? K over M. So if I carry this thing and put here, so I have that A over R is equal to what? Minus omega. Is it? Okay, W squared. Okay, the square of this. So I have this squared. So this one moving here to have that A is equal to minus omega squared R. So this is another important formula you need to know. Then finally, I'm going to have that. Don't forget the formula I told you that. Okay. So which other thing do we need to know here? Then for simple pendulum, you know that simple pendulum is a special type of simple harmonic motion. Okay, simple pendulum is a special type of simple harmonic motion, and everybody knows that the formula for simple pendulum T is equal to what? 2 pi the square root of L over G. 2 pi the square root of what? L over G. And don't forget that your omega is equal to what? 2 pi F. If omega is 2 pi F, then if you want to bring in omega here, and I'm going to have or you know that omega is still 2 pi over t. I hope you know, because f is 1 over t. Now, if you now bring it here, you now have that to make t subject of formula. T subject of formula will now be 2 pi over w. Or okay, I want to bring in w here. So how do we bring in w there? My t is equal to, this is the 2 pi. Okay, my t. Okay, I want to replace two. Okay, this is what? My 2 pi. 2 pi is equal to wt. If you put wt, the square root of L over G. So what do we have? T will take care of t. Okay, I'm trying to get something, but I'm mixing it up. I want to bring in w there. Okay, just know this formula for me, that t is equal to what? 2 pi the square root of L over G, and then your t is equal to 1 over F. Okay, in case they give you that. So the next thing you need to know here is that what? Your V is equal to W the square root of what? The square root of A squared minus X squared. This is another important formula you need to know. This is another important formula you need to know when you are giving amplitude and the rest of them. Okay, so that is that for that. I think I'm done for this video. So thank you very much for watching. Please don't forget to like, share, subscribe. If there's any other formula that I forgot that you remember, please tell us on the comment section. Okay, bye bye. Love you.